Okay, so here's an example where we're going to use the first derivative test to find the critical points and then classify what type of critical point each is. Okay, so for our first example, the first thing we need to do is dive in and take the derivative. Okay, so the derivative of this, just using the power rule, is going to be 15 x to the fourth minus 15 x to the second. Okay, so in this case, I'm going to factor out a 15x squared. So when I take that out, I'm going to take a 15x squared out of both of these, and that's going to leave me with x squared minus 1. Okay, so I can factor this further. Now I know that in order to find critical points, my critical points are going to be where the function is either undefined, which it is defined through a value of x, or where the function equals 0. So I need to set this equal to 0 because there are no undefined points. So then I'm going to take this as 15x squared times x plus 1 times x minus 1. Okay, so in this case, I'm going to have a critical point. So each of these is going to give me a critical point. This is going to give me a critical point right here. Okay, and if I set that equal to 0, x equals 0 is going to be a critical point. I'm going to get a critical point from this value because I'm going to set x plus 1 equal to 0. So x equals negative 1. And lastly, this is going to give me a critical point right here because x minus 1 needs to equal 0. So when x equals 1. Okay, so now what I'm going to do is I'm going to do a rough sketch. And I do this rough sketch on a number line. So I'm going to take this rough sketch and I'm going to say, okay, I have critical points at my lowest value is negative 1. I have a critical point at 0 and I have a critical point at 1. Okay, and now I just don't know what's happening here, but I need to look at the sign changes. I need to look and see, is it going positive to negative, negative to positive, because then I can tell what type of values it is. So we've done the first part where it says find the critical points. We have critical points at negative 1, 0, and 1. And now we need to go and use the first derivative test. Okay, so what I need to look at is what the sign of the first derivative is. Okay, so I need to, right here, I'm going to look at f prime of negative 2. Okay, here I'm going to look at f prime of negative 0.5. Okay, and here I'm going to look at f prime of 0.5. Okay, and here I'm going to look at f prime of 3. Okay, well, you got to take your original function and you got to plug in these values. Okay, if I plug in negative 2, okay, if I plug in negative 2, I'm going to get 15, that's a positive times negative 2 is going to give me a negative times a negative. So I'm going to get a negative, even whatever the values are. I could do it out on a calculator, but I'm getting a positive times a negative times a negative. So that result is always going to be a positive. Okay. And then if I plug in negative 0.5, that's going to give me a positive value. And then negative 0.5 is going to give me another positive value. And negative 0.5 times negative 1 is going to give me a negative. So that means my result here is going to be negative. Okay. If I plug in a positive 0.5, that's going to give me a positive. It's going to give me a positive again, but then I'm going to be multiplying times a negative here. So I'm going to get a negative here. Okay, so that tells me that 0 isn't a local max or min because there's a sign change. Okay, now the last one right here, we're going to plug in 3. So I'm going to get positive times positive 3 times a positive. So that results in a positive. Okay, so using our design of our last chart, so a positive slope is going to look like this, and then negative is going to go down. So this is going to be a max right here. Okay, negative negative is going to result in something like this. So this is going to be neither. Okay, and then negative is going to come down, and then it's going to go back up, so it's going to be positive. So this is going to be a min. Okay, so here's what we found. So let's do a little summary box over here. We found in summary, okay, we found the critical points, and then we're going to classify them. So our critical points in this case are at x equals -1. We have 1 at x equals 0, and we have 1 at x equals 1. And now we're going to classify what type they are. At -1, it is a local max. Okay, at 0, it is it's neither. And at 1, it is a local min.